Energy Radio.
Welcome to Energy Radio. This is episode 44, and today on our first post-COVID live in-person episode, I'm joined by a good friend, John Coleman of Solar Turbines. John, welcome.
Thanks, Matt. So I've got a fairly diverse background. I started out of engineering at Waterloo and joined Nichols Rackie, which was a family-owned construction firm in Ontario, doing heavy industrial construction. Nichols Rackie still exists. It's now Aecon Industrial. I worked there till 1997, and that's where I started doing cogen. Actual first power project was up in northern Alberta for the Diashawa pulp mill. You know, pulp mills all have their own generation, and then we went on to do a combined cycle plant at TransCanada in Nipigon, and then probably the cogen that still exists now would be at the time the Casco cogens in London and Port Colborne. So it gave me a construction background. Unfortunately, back in 1996, Ontario Hydro sort of slammed the door on cogen in Ontario, and we had been working with some engineering firms out of the US, and they asked me to come down and help them down there. So over the next few years, I worked with a couple of engineering firms in the US, and then actually gravitated back to construction, went to the Middle East, and ran a joint venture in the Middle East for a few years until 9/11, and everything sort of changed after 9/11. So I came back and joined Solar Turbines. I had had a history of Solar Turbines. Nichols Rackie was actually a joint venture partner of Solar Turbines back in the early 90s at the production of the IST boilers.
Oh, okay.
So Nipigon, which was the combined cycle plant that I referenced, was the first IST boilers installed in Canada.
Okay.
And we were joint venture with Solar at that time. So I joined Solar in 2002 out of Saudi Arabia, and I was sales manager for the eastern seaboard of the US, and stayed with them until about 2006, when I decided to start my own consulting firm, and did a series of engineering and consulting gigs for a number of different firms over the years. One of the biggest ones was the Molycorp project, which was the rare earths mine in California, just outside of Las Vegas, where we put in 60 megawatts off-the-grid cogen. And then Solar Turbines approached me in probably late 2016 and asked whether I'd ever consider coming back to Solar Turbines and repatriating back to Canada. So at a weak moment, I decided it's time to come home, and came back and assumed the role of sales manager for power generation for Canada. With a few changes in our organization, one of my peers being promoted, I was asked also to take on New York and New England in the last year, which has been interesting with COVID, assuming a new sales territory. So now I'm responsible for Canada, New York, and New England.
Okay.
So that's my background.
Now, usually we're having this conversation with a plate of chicken wings between us and maybe something different in our cups. So for those who are listening, I know a lot more of John's story, some of which probably shouldn't show up on the podcast, but I want to unpack some of the things. So talk to us about, you know, because I think this part's unique in terms of joining Nichols Rackie, and you know, it wasn't just a blind application. You knew there's some layers to that part of the story that are interesting.
Well, as I said, Nichols Rackie was a family-based firm. If you go far enough back, there were three gentlemen working for Adam Clark: Bill Nichols, Dave Rackie, and Bob Lanza. Bob Lanza is now, and has been for a long time, my father-in-law. Back in the mid-'70s, the three of them on a very long car trip talked about starting their own company, and at the time Bob wasn't willing to take that jump, so Nichols and Rackie started their own company, and then fast forward 7 years later, they pulled Bob Lanza in to be their senior vice president. In university at Waterloo, my fiance at the time, Kathy, was a civil engineer student, and both of us were in the same graduating class, and we were engaged in our fourth year. So it was an automatic that she went over to Nichols Rackie. I was a sort of a lost soul at the time and applied to law school and got waitlisted. And while I was waitlisted, the family sort of insisted that I had a job. So they shipped me off. I went to Nichols Rackie, and they shipped me off to northern Alberta. interesting, very cold, but a lot of fun. And really, construction wasn't something that I had ever intended on going into, nor did I ever intend on, working with my wife. We worked together until, we both went down to the U.S. in '97. So it was successful.
Yeah.
It was also a challenge working for your father-in-law. Although by about my third year, I was off into what we call the small projects group, which was managed by a different gentleman at the time. Actually, the guy who ended up calling me about going to Saudi Arabia, fast forwarding.
Okay. And I'm always, like, for new engineers coming up, I'm always intrigued by, different career paths. Many have joined us straight out of school into consulting. But what was it, in retrospect, for you to start in construction? Good thing, bad thing? I
think it was a great thing. My second job, and the one that I actually got to know some of the engineers in this area, was the Nipigon Power Project, and we were the contractor for TransCanada, and as such, we were actually asked to sit in the engineer's office down here in St. Catharines to do a bunch of constructability analysis. And what that showed me early on was that the value of learning construction for engineering and being able to give that input back into the engineering team was invaluable. Obviously, I didn't get the same sort of level of design engineering experience early on, but we got the practical side. And later on, managing divisions of engineering companies, taking that practical side and being able to try to introduce it to the young engineers and say, listen, not everything's book knowledge. And actually encouraging those engineers to get out in the field in their engineering role. Sometimes I found myself at odds with other managers in the company who believed that young engineers should sit at their desk and learn to do calcs. And I was more, I want these young guys to blend their time, sometimes in the field, going out and looking and realizing that what they put on paper, you actually have to build.
Yeah.
And it's very difficult sometimes for somebody who's not actually, welded a piece of pipe or tried to pull a piece of cable to visualize what needs to be done when they're putting stuff on paper. So I think it's a huge advantage, and I think that, what I've been able to do with the engineering firms that I worked for was being able to introduce the younger guys to some of the field engineering.
Right.
Going out, even doing reports, watching to see how stuff's being built, redlining drawings, doing stuff like that, getting an idea of what it is to install what you've designed.
Well, but just one more thing before we go to solar. I'm always fascinated by your time in New York, and I get the sense that there was a lot going on, the NYU stuff, the Superstorm Sandy. In a nutshell, like what you were banging hard at that time in New York.
Yeah. So as I said, I had the time with the Molly Corp project, which was about from 2009 to 2013 to get it fully up and running. When I finished that, one of my good friends sort of said, "What are you going to do next?" And we were actually on a ski lift together. There's a group of us who, business associates, who've now up to about 14 years of a ski trip. And a lot of businesses talked about over a lot of alternate sort of beverages and a bunch of skiing. And I said, I don't know. I'm looking for my next challenge. And Superstorm Sandy had just happened, and this company had been engaged by NYU Langone Medical Center to assist them with the recovery efforts. So they said, would you consider coming to New York? Even though you are a consultant, we'd like you to take sort of a management role within our New York office and help us with that. So in this case, there were two sides to the recovery effort. One was the insurance side, and the other was actually dealing with FEMA to talk about the recovery. So I was assigned to that portion of it, which was a real eye-opener. Yeah. It was a lot of work. It basically resulted in a FEMA recovery effort for NYU of over $1 billion. The infrastructure portion of it was $440 million. And it, again, a big eye-opener, especially about talking about design and resiliency going forwards. because New York, you know, most of the utility assets were underground. And even the ones that were above ground got impacted by water at ground level. For instance, you had diesel gen sets on the roof. However, the day tanks were in the basement with vents that were below the flood level. So what happened was seawater got sucked into the vents, pulled up because of the way the piping was set up, pulled up into the generators, and the generators failed. So it was an interesting time. And on top of that, we were also being very active with a bunch of cogen, again, resilient type cogen. We got the opportunity to be the design engineer on the Hudson Yards cogen, which was a fascinating microgrid project. It was the first time that Con Edison, the local utility, ever permitted any microgrid to strand utility assets inside the microgrid. So we actually stranded 24 utility connections inside the microgrid, essentially separating off an 8 square block area within the Con Edison grid. The design was the first time it had ever been done. There was no design specifications. Based on a relationship that we had with Con Ed at the time, funnily enough, Con Ed was actually very interested in the fact that during my co-op years I worked for Ontario Hydro, and that seemed to gel us together. They allowed us to write the specification, and highly successful job, fascinating work. But yeah, New York was fun times. You know, in the office every morning at 6 a.m. and at 6 p.m. walk out of the office, and either my wife and I are going out for chicken wings and pool, or I'm going out with customers.
Right.
And then Saturday morning in the office for 7 till noon, Sunday morning in the office 7 to noon. It was an energetic time.
Right, right.
I'm very happy that I wasn't there during COVID, that we had left, but certainly don't regret it. Really enjoyed it. The challenges, especially the logistic challenges in constructing anything in New York, real eye-opener. Makes downtown Toronto look wide open. The other thing that was really a challenge was, you know, understanding the requirements of specifications, understanding the utility requirements. Con Edison is probably one of the most difficult utilities I've ever dealt with in terms of interconnect, electrical interconnect, steam interconnect, and gas interconnect, all having the very unique idiosyncrasies that we might not see in other places. And then finally, specifications and authorities having jurisdiction. When it comes to cogeneration, the building authority in New York turns all the review over to the FDNY, the fire department, specifically dealing with hazards such as medium and high pressure gas supply.
And is that a post 9/11 thing?
No, it's got more interesting post 9/11. But really what's happened to the codes in New York is every time there's been a disaster, the codes get more stringent.
Right.
And it started a long time ago. It started almost 100 years ago with a massive fire. New York had a lot of industry, clothing industry in downtown, and there was a massive fire in a clothing mill. Killed a lot of people, and really just because there were no fire exits at the time. And that started to grow the code, and the code gets updated on a regular basis. Now 9/11 certainly introduced an awful lot to it. Hurricane Sandy has now changed it again, you know, raising primary utilities above the flood zone. But a real challenge, and certainly from a design point of view, being able to understand the requirements and also being able to form relationships with the authorities having jurisdiction so that you can properly shepherd your project through the massive sort of red tape and be able to bring jobs in on time and schedule.
Yeah. Cool. So then you leave, so let's transition now. You leave New York, you come north, you come home, and you land with Solar Turbines Canada. Talk to us about solar turbines. I think people often are confused. Solar turbines, how does that work? Talk to us in general about the company, a bit more about your role into it, and then we'll go deeper with solar.
So my joke about solar turbines is we're so good we can run at night. After that, I tell people that we actually burn stored solar energy, and that gets a few head scratchers going. So, for those who don't know, Solar Turbines is a combustion turbine manufacturing company established around 1926 in San Diego. Originally, it was an aircraft aircraft parts manufacturing company. During the Second World War, Solar Turbines worked with the U.S. Navy on their jet program. We actually developed the first afterburners. And then in the late 40s, Solar Turbines started to manufacture combustion turbines and has done so pretty much ever since. We also manufacture compressors that match up with those turbines. Solar Turbines was, until 1982, owned by International Harvester and got bought by Caterpillar in 1982. At that time, when they made the purchase, they incorporated an entity in Canada, Solar Turbines Canada, which is actually a wholly owned entity of Caterpillar.
Okay.
Solar had been quite active with the Canadian government in the 60s and 70s with a lot of our smaller units, our Saturns, which still exist, and our Spartan units, for a lot of backup power, hundreds of them, in fact. So solar was not new to Canada when they incorporated in 1982.
And the solar cat, I mean, solar, there's an ownership, but there's a lot of autonomy. Like, solar really is its own organization for the most part?
Correct. So solar is really an independent, vertically integrated company. And when I say vertically integrated, I mean we manufacture our product, we sell our product, and we maintain our product in aftermarket services. Whereas Caterpillar manufactures a product and then goes through the dealer network to sell the product and in some cases maintain the product. Now, that's an interesting thing for the Caterpillar organization because Caterpillar does tend to use solar as a training ground for some of their executives who are able to see a vertically integrated company. Case in point, the current CEO of Caterpillar, Jim Umpleby, was actually my boss at Solar Turbines way back when in 2002 when I worked there before. And Jim actually started as a young engineer in our engineering group and worked his way up through the company.
Really? Wow.
Our current president, Tom Paulette, was a senior executive vice president of Caterpillar, coming out of the solar organization, and now has returned back to solar to be its president. So there is a lot of sort of back and forth at the executive management level, and I think, you know, my opinion is because of the nature of solar, it gives a good broad perspective to the individual that can be, you know, used at the Caterpillar level.
Right.
But you are right. Solar is less than 10% of the full Caterpillar revenue, so we don't even have a separate set of books for the CEC filings. We're just a line item in the Caterpillar filings.
Okay. Okay.
But a valuable piece of Caterpillar since 1982, and certainly. You know, we advertise that as being a Caterpillar company.
And within solar, you have kind of, in general terms, you have kind of two divisions or two verticals and two products, right? You have, you know, two kind of markets that you approach, and you have only one product for one market. But talk us through kind of the divisions of. So
correct. We actually have three market-facing divisions. Okay. In terms of the products, two of them are our industrial power generation and our oil and gas division. Our third division is customer services, which is aftermarket sales. Since we have 16,000 turbines that have been installed, and many of our turbines run well past 30 years, you can understand that there are a lot of turbines out there that require maintenance. And depending on the market, we sometimes do all of the maintenance, and sometimes we just do a smaller subset. But it's now growing into a fairly large portion of our company. But within the actual sales portion, new equipment sales portion, you're correct, there are two sides. Industrial power generation, which is the side that I represent, you know, hospitals, universities, manufacturing facilities that want to put in usually cogeneration. Okay. And then our oil and gas side, which would be midstreamers, transportation, distribution, pipeline companies. And they're putting in a variety of different turbine-based products. They're either looking at a turbine with a pump, a turbine with a compressor, or a turbine with a generator.
Right.
So our oil and gas guys actually do sell generator sets. Now, typically, the units that are sold into our oil and gas markets, while the turbine is the same, the packaging is a bit more robust, API standard, so there's a bit more to it. Whereas in industrial, our packaging is for non-hazardous locations. But again, the turbine is the same turbine.
Right, right.
We do have products that are sort of unique to oil and gas and products that are more unique to power generation. But with the current drive for resiliency, carbon reduction, we are seeing quite a crossover now between our oil and gas and our power generation markets, where oil and gas companies are very interested in the high efficiency of combined heat and power and are actually looking to our oil and gas side to provide them with more traditional PG products.
I see. Okay. And in that PG market, power generation market, like, talk to me about size range, what types of, you talked about types of projects, but talking about size range, and then we'll talk about kind of fuel and what you're seeing in the industry.
So the current product line for solar extends from our 1.2 megawatt Saturn.
Which, by the way, if you want to buy one, John will sell you one.
I'm happy to sell you Saturn. I have actually sold 3 Saturns. It's a bit of a joke. The product is certainly not a joke. We have 5,000 of them out there. It's a very robust, bulletproof little package. As such, it's not cheap. It's an expensive package. And it tends to be used more in severe environments, oil and gas environments, and that's why we've sold 5,000 of them.
Yeah. Within
cogeneration, it tends to be not as popular a package because it's small and it's expensive.
Yeah.
But I have sold 3 of them, and they've been very good applications. We extend there all the way up to our Titan 250, which is a 21 megawatt turbine, actually now uprated to 23 megawatts.
Cool.
Through a number of different product lines. Probably our most successful products at the moment would be our Taurus 70, which is about 8 megawatts, and our Titan 130, which is now rated at 16.5 megawatts. And then the Titan 250 has a big brother coming. More to come on that. We'll have to do another podcast.
Look forward to it.
It's not in manufacturing, but there is a future product coming in the bigger range that we're already starting to look with customers with.
Okay.
So yeah, our product line extends from 1 to 23 within the power gen market. Again, the Taurus 60, which is about 5.5, the Taurus 70 at about 8, and the Titan 130 at 16 are the real sort of bread and butter products for our power generation.
Right. And when you deliver a product, talk to me about what solar in North America, what solar is providing to a project. Is it just the turbine? Is it like, what is that you guys typically deliver?
It's important to note, what do we do in North America? Solar Turbines does provide EPC services to our overseas market, and we do that quite a lot. Within North America, our normal scope of supply is equipment. So normally we are providing the turbine package itself, which is a skid-mounted turbine, gearbox, and generator, with some ancillary equipment. The package comes in a box, sound attenuating, weatherproof enclosure, and then either adjacent to that or on top of that, we've got our package ventilation system, our combustion air system, and then our lube oil system. And that's usually the base supply. We do have some customers, we've got a couple right now, who ask us to also supply some of the power island equipment like the heat recovery steam generator or the fuel gas compressor. They do that because they want a single point responsibility, especially with respect to performance and emissions. It means that, at the stack, they only have one person to deal with as opposed to having multiple. And then on some lesser occasions, we do get asked if we can provide installation services. It's not as common in North America. The last one we did in Canada was Queen's University, which was a couple of Taurus units. And then most recently in the U.S., we put in a Titan for Nantucket Electric, where we actually provided the EPC services. But generally, our focus is providing equipment.
And you have in terms of providing the equipment now, you have kind of a new iteration. Speak briefly about the PGM module.
Okay. So, as I said, our package is a turbine generator gearbox in a sound attenuating weatherproof enclosure. And I also mentioned that we tend to do much more construction services overseas. So our European group, who handles a lot of our overseas work, being the fact that they traditionally provide EPC services, have over the last 10 years developed a more modular type package, which we have now introduced into North America. It's called the PGM, or Power Generation Module. It's still a box that contains the turbine generator and gearbox. However, the frame itself is lighter, and the box is a drop-over enclosure. As such, the box is designed structurally to be able to now support all of the ancillary equipment, the ventilation system, the combustion air system, the lube oil system, on top of it, and in a very modular format. In addition, we've connected a small electrical enclosure on the tail end of this, which allows us to put the MCC, the backup battery system, and the VFDs in there and have them pre-wired to the equipment on the skid. So what this has done is it's made a smaller footprint, because you don't have equipment sitting adjacent to it, you've got it sitting on top. It's also decreased the amount of time it takes to do the install, because now you've got pre-wired systems. The piping, even to the lube oil, comes spooled for quick field installation. And we're looking at installation times drastically reduced from a more traditional turbine in a box solution. And we've got a lot of customers who are very interested in it. This product is a very good product, particularly if you're going to be putting it outside and you don't have a building over top.
Right.
It makes for very quick installation. We've got a lot of customers that are now starting to realize the amount of savings that they've got in terms of labor and time. So it's a product that's now available currently for our Taurus 70 and our Titan 130, and in the next year or two is going to be available for what we call our universal skid, which is the Centaur 40, Centaur 50, Taurus 60, Taurus 65, which are all on a common skid.
Gotcha. I've never asked you this about the PGM, but do you do a shop fit up before you dismantle it and send it to site?
So the PGM, it's a shop fit up with the exception of the generator.
Oh.
So
all the ventilation stuff gets fit up before you send it out?
It gets fit. Currently it gets fit in San Diego, at least to match mark everything. The generator does not. When they do a test, they're testing against a slave. The generator meets the equipment at site. Oh, really? For installation at site.
Really?
Which, because we use Cato Leroy Summer, it's not a risk because we know the equipment very well.
Is that because of the weight? Like they can't ship because of the frame, the lighter frame?
That is partially the reason. I mean, traditionally the Titan 130 is two packages that get bolted together at site.
Right.
This allows us to ship a single lift module to site, and then the generator comes and it gets put into spot. So we are doing package testing, but unlike the legacy package where everything is on the skid for the dynamic test, the generator is tested separately. Yeah. And actually, we've had a fair number of people wanting to shift to that model. The dynamic test does add some cost. Yeah. But because of the amount that we do it, we're very comfortable with the product and the results we would get from a test.
Well, and it's a good excuse to get down to San Diego.
It's always a good excuse. Now, that being said, even though we don't have the generator there, we still do green run testing and various other things. So there's always an excuse to come down to San Diego. And that is one of the things that I highly encourage any of my customers to do, is come to San Diego. Because especially in the power gen world where, this is, I call it a generational purchase. Many of our power gen customers will only ever purchase one turbine in their lifetime. Right. Whereas our oil and gas customers are doing regular purchases. So being able to come down to San Diego, you get a much better feel of what the organization is and what, how we put things together. Yeah. And, I think it's important to understand that. It also gives people more confidence in the product they've purchased. Yeah, yeah. The other thing is getting an opportunity to come down and meet with our project management and engineering teams, especially if there's questions on design. It's a great opportunity to be able to have those sort of face-to-face meetings in a non-COVID world.
Right.
Face-to-face meetings, and obviously a chance to get out on the boat.
Yes.
You know, the boat cruise is always fun.
Yes, yes. We won't explore that any further, but let's move to fuels, and I want to park the H word for a minute. We'll come back to that in a minute. But before we get there, what other fuels, like we've talked about natural gas. That's easy. It's clean. It's coming out of the pipe. But what other stuff are you burning these days?
So, first and foremost, solar burns two types of fuels. We burn a gaseous fuel and we burn a liquid fuel. And our dual fuel units have the ability to burn both separately at separate times. We don't actually co-fire. So we can burn, as I say, gaseous and liquid fuels. For a long time, we have been able to burn alternate gaseous fuels. We've got quite a wide spectrum. Turbines, just by the nature of them, can burn very low BTU fuels. We can get down below 400 WOBE, approximately 400 BTUs per standard cubic foot, and we can go up to over 1,200. And that gives us the ability to burn a lot of different types of alternate fuel. Historically, since the 90s, we've been doing a lot of landfill gas and biogas fuels. We call these the low BTU fuels. Now, it's interesting, our current product line, ever since the late 90s, has been dry low NOx for normal natural gas combustion. It's like a lean premix system. Our low BTU fuels we actually have to burn in our conventional system. But because they are low BTU and we have so much air put in, it naturally acts as a lean premix system.
Oh, interesting.
So we're actually able to burn landfill gases and get very similar emissions to the sort of traditional dry low NOx systems for natural gas.
Okay.
So solar has a lot of experience in the low BTU market. So we really have been burning renewable or waste gases since the mid-90s. As I say, predominantly in landfill gas and digester gas systems.
Right, right.
With respect to liquid fuels, it's a bit more narrow, predominantly because that's the way the market's been. We are now starting to see the introduction of biodiesels.
Oh, yeah?
But typically, liquid fuels are being used either as a backup fuel in North America, or they're being used in an offshore location where it really is diesel.
Right, right.
So our wide fuel acceptability has been more in our gaseous fuel systems.
Now, in the oil and gas segment where it's power gen, are there high BTU like gaseous, like are they burning propane and stuff like that? Or?
Yeah, so we definitely have a variety of different fuels in the gas, the oil and gas market. Probably the biggest is sour gas.
Okay.
So the challenge there is obviously sulfur.
Sulfur, yeah.
Solar can take a very high level of sulfur. Turbines themselves, sulfur in equals sulfur out. It doesn't tend to be a problem within the turbine itself, other than some typical safety precautions you have to take for H2S and various other things that can be in the fuel. Where sulfur can be a problem is downstream in the HRSG. Although with proper design, we're doing a job now for a wastewater treatment plant in Calgary, where the sulfur content will be in excess of 3,000 ppm, and the turbine we've given permission to be able to burn it in the turbine, but we had to come up with a bit of a different design on the HRSG. In terms of propane, traditionally propane has been a backup fuel and usually has been a liquid fuel that they vaporize. And what we've been doing is adding some air to try to blend it from a hot fuel down to more of the same as natural gas.
Gotcha. Okay.
Hot fuels can pose a few problems, typically on emissions. People who understand the stoichiometry behind, combustion understand that lower temperature flames make more carbon monoxide. Higher temperature flames make more NOx, nitrous oxides. And so the hotter flames become a bit of a challenge on the NOx. So if we can blend it down to bring our NOx emissions back into range, it's better.
Gotcha.
But yes, we certainly get asked to do a bunch of the ethanes, pentanes, propanes.
Right, right.
But really predominantly in oil and gas. If it's not natural gas, it's going to be some kind of sour gas.
Yeah, okay. So let's now move to, and the listeners of the show know my phrase about how these days you can't swing a dead cat and not hear hydrogen. So talk to me about, I know you have an approach to hydrogen, and then there's kind of the practical realities. Talk to me about hydrogen.
Well, what I say these days is hydrogen's got the best marketing team on the planet. There is a huge difference between the reality and what's actually people want. So the truth is, this is not new to solar. Solar has been dealing with hydrogen since the 90s. In particular, we got very involved with coke oven gas applications overseas, which can be in excess of 60% hydrogen. So solar has been able to burn relatively high hydrogen for over 20 years. One of the things that's newer, although we have been doing it for a long time, is the ability to blend hydrogen into natural gas and still have the same emissions that we would on natural gas.
Do you do, I don't know the answer to this, do you do 2 fuel trains? Do you do before the fuel train?
No, this is before the fuel train.
Before the fuel train.
So the expectation is that either the customer is able to purchase a hydrogen blend from their gas supplier.
I see.
Or they have a source of hydrogen at site that they're going to blend in.
Okay.
And this is where reality sort of sets in. At the moment, being able to purchase a blended fuel stream is not really available in North America. They are doing it to a certain degree over in Europe. In North America, there are a bunch of hurdles with respect to the fact that blending any hydrogen into the gas stream will have downstream effects, particularly with residential.
Yeah.
So right now, with the exception of the Mercury 50 and the Taurus 65, solar is able to accept a blended fuel up to 20%.
Okay.
And still maintain our regular dry low NOx emissions requirements. If somebody wants to just do a high hydrogen fuel themselves, we're in excess of 80%.
Okay.
But the emission profile is going to be different. You're going to get much more NOx.
Right, okay.
So we have tested to this. We have units actually running in the field. But again, right now, typically it's a requirement that customers want, and they want to have that. It's more future-proofing.
Right.
It's not something that's happening, in general at the moment. But we're very bullish on being able to drive that blended mix even higher than 20%. We have some customers right now on 2 different projects that are going to happen in the future, looking for upwards of 30%, which is a target. Similarly, we've got a lot of people who want us to sign up to 100% high hydrogen fuel, which is a target for us as well.
And is that an R&D effort to get there? Like you're changing materials of construction? Or?
Definitely.
Yeah. Okay.
So there's a few different things that we have to keep in mind when you introduce hydrogen into the combustion system. First off, hydrogen embrittlement. Hydrogen does have an adverse effect on regular metallurgies, so we have to make sure that the metallurgies that we use in our fuel streams aren't subject to hydrogen embrittlement.
Right.
Second is the hydrogen molecule is particularly motile, which essentially means it's a little tiny guy, and it's really good at getting through seals and gaskets.
Could we get that word on the screen? Motile.
Motile.
You have to check this.
I learned that. So the negative impact of that is places that we don't expect to have a combustible material,
right,
all of a sudden the combustible material can appear. So we have to make sure that we take that into consideration in our seal and gasket designs so that we don't have an explosion problem,
right,
frankly. And then finally, hydrogen itself, it's a hotter fuel. And we have to look at not only the chance of flame impingement on the burner itself, which means, when you look at, if you light up a butane torch at home to braze some pipe, the first bit of the flame is clear, and then you actually see the blue part of the flame.
Right.
The hydrogen the flame actually gets closer and closer to the tip, and that can cause erosion of the tip. So we have to take that in consideration. And then finally, as we said before, it's a hotter flame, which is going to increase the amount of NOx production. So we have to look at that as well.
Right. Okay.
So those are the primary things that we.
So from your vantage point, hey, we can do it. We're going to keep ramping up the level we can do it, and at the current rate, you're probably going to be ahead of what the market can practically supply.
Yes.
Yeah.
And in saying, hey, we can do it, I guess I'd say, hey, we are doing it.
Are doing it, right.
And have been doing it for over 20 years.
Yeah, okay, cool. Let's put your, well, to the best that you can, take off your Solar Turbines hat for a minute and put you used to be one of us as a consultant. Let's talk about engines versus turbines. Let's talk about, how do we, if you're looking at a power project, where, what are the benefits of each? Kind of walk us through, at a high level, a comparison between the two technologies.
So the good news is I can take my solar hat and my Caterpillar hat.
Aha.
So as such, I have to be, yes, I've built reciprocating engine plants. I've designed reciprocating engine plants. We are a subsidiary of Caterpillar. So I have to be very familiar with recip engines and have to understand them. Because they are a very viable technology for power generation and for combined heat and power. The technologies are different. There's advantages and disadvantages to both. Certainly, recip engines generally are better suited to low thermal recovery situations. They don't have a high exhaust temperature. So they've got a lower exhaust temperature, and they've got a great deal of even lower temperature waste heat coming off the jacket, coming off the lube oil. So if you're in a situation where you're looking at combined heat and power and you're able to use low temperature heat, in the sort of 50 to 60 degrees C range, and then in the 80 to 90 degrees C range, that gives you the ability to maximize the amount of heat recoverable off of a recip engine. The exhaust itself is not really suited to making steam. It can, but it's a very low amount of steam. So if you were to rely on a recip engine for a steam-based CHP, you would probably be less than 65% efficient. But if you're able to get the medium temperature hot water recovery, you can get up to 75. If you can get the low temperature, you're probably getting up to about 85% recovery on a lower heating value basis.
Right.
Other advantages of recip engines, they are very easy to operate. For the average person, average operator who knows how to maintain a car, they can figure out how to maintain a recip engine. And the product itself is a bit less expensive. Certainly in the sort of 3 to 5 megawatt range.
Right.
Things do change as you get into the larger recips, the more sort of marine-based recips, things change. Turbines, on the other hand, are better for a higher heat application. You make a lot of steam, and because of the excess amount of oxygen in the exhaust, we're able to duct fire and, again, throw efficiencies above 85% with extensive duct firing. The turbine is more expensive from a CapEx basis, but generally less expensive from a maintenance basis because we're not doing spark plug changes, we're not doing lube oil changes, which increases the availability of the unit, and decreases the maintenance cost. So really, the first thing I will always say to somebody is really understand what you need. Generally I get people calling up saying, I need 5 megawatts of power. Well, when you're talking about CHP, the secret sauce is not the electric side. The secret sauce in the whole thing is the thermal, matching the thermal to your prime mover.
Right.
And understanding not only what you think your average and peak load are, but what your load profile looks like. So there is, a lot of applications that it's very clear cut. It's going to go recip engine, and very clear cut. It's going to go turbines. So understanding that's important and realizing that there's good applications for both.
Right.
And typically for me, it boils down to, looking at the electric and the thermal load profiles, how they match up together, and the type of thermal energy that's being used.
Yeah.
And that tends to drive it one way or the other.
Yeah.
There are other extenuating circumstances. If you're looking at simple cycle,
Right.
you know, reciprocating engines tend to be a higher efficient unit, which means in simple cycle, things tend to slant towards recip engines. However, we do have situations now that that whole side of it changes. When we are burning flare gas and waste gases that have a zero cost to them, in fact, you want to be able to burn more rather than less.
Yeah.
The efficiency goes out of the equation, and really it comes down to an evaluation of CapEx versus OpEx. We have a series of projects that we are looking at in Western Canada where the goal is to burn waste gases. And when you do a life cycle analysis on the total life cycle cost, turbines win out because efficiency's gone out the window.
Right. Okay.
Because there's no heat recovery and there's no value to the fuel. In fact, there's a value to burning the fuel rather than flaring the fuel.
Right. Gotcha.
To make electricity.
So in that life cycle cost, you talk about operations and particularly maintenance. Talk to me about what you've seen work well on turbines with long-term maintenance. What Solar's strategy is. What the key things to look out for are. So
I think I need to first and foremost say that there's a real difference in the approach to maintenance between our power generation customers and our oil and gas customers, and then the larger independent power customers.
Right.
The larger independent power customers approach maintenance differently than Solar does. Their products are different. Within Solar, most of our power generation customers, because they are generational type purchases and they may only have one, and turbines are sort of unique in terms of maintenance. Your average car mechanic doesn't maintain turbines, just like they don't maintain airplane engines either. So what we do in Solar is we offer a full service agreement where we do the regular maintenance, we do the preventative and unplanned maintenance, and we also do the overhauls. And that's packaged up into a single product. The risk, we de-risk it by charging the customer on a price per month basis. We offer availability guarantees, and it includes all overhauls.
Right.
And our overhauls are not field overhauls, they're engine swap outs. So when the time comes, either planned or unplanned, because there's always unplanned events, anybody who says there aren't is lying to you. We roll in with a rebuilt engine that gets put in, started, and then 4 years later we do it again.
Right.
So that's our product in PG, in power generation. Our oil and gas customers, some buy that product, but most don't. Because they've got multiple units, they're far more comfortable with doing some of the regular maintenance. And then they'll buy things more on an a la carte basis. Or they buy it on an equipment health management basis. One of the things that we include in our long-term service agreement, which we are now including in our health maintenance package for oil and gas, is our Insight system, which is remote monitoring diagnostics.
Right.
We've got over 2,500 units connected to that, and we're doing a lot more predictive maintenance. And this is allowing us to increase availabilities, start to get to an annual maintenance rather than a biannual maintenance, and also give the customer visibility to how the unit's operating in comparison to the rest of the fleet.
Gotcha.
So they can benchmark their operations against the rest of the fleet.
Huh.
And it's become very attractive even to our oil and gas customers who aren't buying the full service agreement, but they buy an equipment health agreement that includes that.
Right.
So that's an important point of our process that we're using in our long-term service agreements.
Right. Okay. Cool. So John, we live in a world now where it's all renewables. In some parts of North America, natural gas, any incremental natural gas is a no-no. What's the future for solar in terms of the power landscape in North America, and you have this public opinion around carbon, and then you have the practical realities of the world we live in. What's your view or Solar's view of the next 10 years?
Well, certainly it's a difficult sort of crystal ball to look into.
Sure.
I can say that in the last 3 years, it's been almost sort of an exponential change within the market to drive towards carbon reduction, carbon elimination, and alternate fuels. You know, solar still stands very hard behind combined heat and power. We see combined heat and power being a huge bridge towards carbon reduction. Because of the high efficiency compared to grid, we're able to lower carbon that way. And we still believe that natural gas is definitely a fuel that has to be considered for many years to come, but it has to be applied properly, which is generally high efficiency. With respect to the market, we continue to see a lot of natural gas-based systems using high efficiency, but also for resiliency plays as well. And we are seeing the drive towards alternate fuels growing at this exponential rate. So really our path forwards and our belief is that we continue to offer a very wide fuel suitability so that, you know, if somebody wants to burn waste gases, biogases, hydrogen, you know, we're able to handle that and do that properly.
Yeah.
And that's really very important.
Yeah.
You know, the reality is that we see what happened in Texas. We see, you know, what happened with the ice storm in Canada a long time ago, maybe not so long ago, what happened with Hurricane Sandy. And, you know, if you take a picture of Lower Manhattan during Hurricane Sandy, there is only one area that's lit up, and that was NYU, the university at Washington Square, with their turbines. So it's going to really be important to remember that power generation and resiliency is very important, but we've got to add the sustainability in, which is what we're doing. And we believe that's a big emphasis that we have.
Yeah.
So continue to drive towards, you know, higher non-carbon fuel suitability like hydrogen, being able to, you know, continue to work in high efficiency type modes like CHP. You know, that's really going to be the bread and butter. Yeah. Certainly within North America, there are various regions that are handled differently. Canada in the west and in the east handle things very differently, even province to province. The provinces that have a lot of hydroelectric, like Manitoba and Quebec, you know, are looking at things differently than we would normally look at them in Saskatchewan and Alberta, where they still burn coal, and actually natural gas is seen as the next phase of coal reduction. Right. We're getting the same thing in the U.S.
Yeah, and I think what's important too is to separate the fuel from the technology, right? And so the fuel piece will have to figure itself out. But if you look at in Texas, you know, you have wind and solar that is good technology, good fuel, but subject to the elements, right? Whereas in what we do, what you guys do, everything is, you know, inside, it's enclosed, it's underground, you know, they're, to your point, you know, south part of Manhattan, you know, continuing to run, right? That the technology is still strong and getting better. We got to figure out the fuel side, but the technology at its core provides that resiliency piece, right?
I would agree. And that actually leads to probably some opportunities that we've been looking at, which is co-locating, you know, turbine-based technology with, you know, the traditional wind and solar.
Yeah.
You know, to make sure that you have resilient power there when the wind's not blowing in the middle of the night.
Right.
Being able to co-locate that is a good way to hedge the bets against problems with resiliency.
Yeah.
And that's going to be important as well.
Yeah.
And because turbines, you know, continue to have very low emissions compared to, even with natural gas, compared to reciprocating engines, we are starting to see more requests from industries that typically have been using diesel recips in the past as their backup. We're starting to see more data centers try to transfer over to natural gas-based backup as opposed to diesel-based backup. And one of the advantages of turbines is the dynamic response running on natural gas is very good. So it's been an attractive backup technology.
Yeah. Cool. Good. Well, John, this has been fun.
Well, thanks for having me. I really appreciate it.
Yeah. If people want to get a hold of you, what's the best way to find you or find Solar? Or
I just call Matt.
Just call me. All right.
No, if you Solar's got a great website. If you need me, I'm just jcoleman@solarturbines.com.
Cool.
And very easy to get in touch with. I would
And
highly encourage people to look at the website.
Search solar turbines. You got to get solar
turbines.
Yeah, good. And I can't leave without talking about the coif, the COVID hair.
This is my COVID haircut. This is a year. And the plan is that when I am deemed worthy to get my second vaccine shot in Canada, I am going to get my hair cut for charity. My wife and I support the Halton Women's Shelter, and looking to do sort of an online fundraising for them.
Cool.
And depending on how much I raise is how short it's going to go.
Okay.
Might do the full Yule Brenner.
Okay.
But again, that'll be probably midsummer, maybe later on in the fall for the Halton.
It's triggered by the second vaccine.
Second vaccine, not just the first shot. I need my second shot.
What if you get? Is it AstraZeneca? If you get a single shot, then you're okay, right? If you get
well, we'll have to see when that comes.
All right.
We've been told by our government that we take what we're given.
Right.
And I guess if they're only going to give me one shot, then I'll have to take what I'm given.
Well, what's important though is the more money you raise for the Halton Women's Shelter, the closer you go to the wood.
Yes.
All right, good. Well, for those who are listening that are friends of John Coleman, or JC as he's known in the U.S., donate a lot and often so that John goes right to the bone. So thank you, John.
Thank you.
It's been fun. On behalf of Mark, who's behind the camera, and Lisa, my co-host who couldn't make it today, I'm Matt Lensing. Thank you for listening to episode 44 of Energy Radio with John Coleman of Solar Turbines. Until we're together again, have fun and be safe. Bye.